Awesome. Hi, everyone. That was quite
Hello.
the intro. Well, happy afternoon. It's been a long day, so thanks for hanging in here with me. I'm Monica, product manager for Keras, and today I'll be talking about Keras and the ways it makes deep learning easier. In particular, I'll be giving you an overview of how you can train your JAX models with Keras. Heads up, this is going to be quite a technical session. We'll be kind of diving deep into the various APIs of the Keras deep learning framework. So if that's what you're interested in, then you're in the right place. Okay, cool. So as I explained earlier, the Keras ecosystem provides many on-ramps to using JAX. What is JAX, you ask? It's Google's high-performance numerical computing framework. It's what we use at Google to train Gemini. But back to Keras. So I think of Keras as a toolbox for all your deep learning needs, right? It comes with various optimizers, losses, check pointers, all that work with our special training abstraction model.fit. So here's like a little gardening tool shed to demonstrate that abstraction. And this is Keras kind of in its simplest form, right? So you can train or author and train a model in just 7 lines using the Keras API. So what exactly is inside Keras? Well, we have, our ops and layers, all of which work together to create your model, which you can build using, the functional or sequential model building patterns. And then, of course, we have the model.compile, model.summary, model.fit APIs, which I'll go into later. We got optimizers, losses, metrics, callbacks, multi-device distribution, which I'll give a brief overview of later as well. And of course, all of these things work together with model.fit, the Keras training abstraction, and that's also, one of the key APIs that make the Keras identity. Keras, I think my favorite part about it is the fact that it was designed according to the progressive disclosure of complexity. So what this means exactly is everything in Keras, you can start with it in its simplest form, and then of course you can drill down deeper to access higher levels of complexity. So we can see how this works with model.fit. First, we have model.fit in its simplest form. Just, you create your model, you compile it, and then you just call model.fit, passing in your X train, Y train, and then a couple of other parameters. Of course, we can also customize model.fit with callbacks. So here we have the Keras early stopping callback, which you can use to halt training if you reach a certain metric. Next, of course, we can zoom in a little bit more, and we add a multi-device distribution, which is a way of sharding your model across multiple devices so you can do distributed training. Here we define the device mesh. Next, we have our layout map, which defines the sharding configurations of our tensors in each of the layers. And then we can also specify the distribution strategy. So there's 2 options, model parallel or data parallel, and then we can set those in the Keras.distribution global distribution context. And then, of course, as promised, it all works with model.compile and model.fit. We can also customize every part of the model.fit training loop. So here we override the compute loss and updates function, which is then called automatically by the model.fit train loop. And so because of the way that Keras was designed, you can start with it in for very simple use cases, and then you can continuously customize it. We like to think of it as being made for everyone, right? So it can fit your research, experimental, or applied machine learning needs. I personally love this slide. I feel like it gives me a sense of like optimism and hope, and you can't even tell it's for like a Python package based on the image. So that was Keras. So far, we've been focusing on how it works on top of JAX, which again is one of Google's newer machine learning frameworks. But if you didn't know, Keras also works with TensorFlow and PyTorch, and actually used to be part of TensorFlow until 2 years ago. And so the way you specify the backend is really easy. We just take a look at that environmental variable and we can switch it. Right now it says JAX and then TensorFlow or PyTorch, and note how the code beneath it all stays the same. Pro tip, many people like to mix and match their choice of data pipeline with their model training framework. So I know these days TF data is really popular, and the great thing about Keras is that you can use a TF data pipeline with JAX in order to train your model. So this is an example here. We use tf.data dataset, and then we use model.fit on a JAX training, on a JAX model. Here's a little bit more about our ecosystem. So there's Keras at the bottom, or at the middle there, and then of course we have our domain-specific packages, like Keras Hub and Keras Recommenders. So yeah, that was just kind of an overview of the Keras ecosystem. I hope most of this was familiar to many of you in the room. Keras has been around for 10 years, so it's definitely had a long presence, I think, in the open source ML communities. Now I want to transition to talking about Keras Hub, which is our Keras model garden, which came out in 2023. So what it is it's our collection of pre-trained models that work on either TensorFlow Keras or TensorFlow JAX or PyTorch. We have many of them, right? 200 plus model variants, 44 state-of-the-art model architectures. And here's just a selection. So you'll see kind of the hottest and latest LLM architectures are all there. So yeah, we at Keras, take a lot of pride in being able to offer such a wide array of models. The way you get started with Keras Hub is super easy. You can just download it as a pip package, and then choose your backend, import it, and then there you go. You can just call Gemma calls a LM from preset, and then that's how you get Gemma. And then what can you do with that? You can use it to generate tokens. You can also fine tune. So here we call model.fit on that Gemma LM object. So super easy. And the great thing about Keras Hub is that it works with both Hugging Face and Kaggle. Here you can see we have all of our models available on Kaggle. And then the great thing is each of the models also comes with kind of quick start guides for how you can, to teach you how you can get started with these models. And also there are other like community contributed guides too on each of these model pages. Same goes for Hugging Face. We have all of our models on Hugging Face as well. And yeah, you can also download our model presets from Hugging Face. So now let's go into model presets. So what is a model preset? It's a directory containing the config, checkpoints, and file assets of your Keras Hub model. So just, I think many people from Hugging Face, or if you're used to Hugging Face, you're used to the API from pre-trained. Keras Hub from preset is very similar. You can call .from preset on a built-in Keras identifier, so you just are pulling the default weights in Keras Hub here. Then you can also do the same with a Kaggle URL. or a Hugging Face URL. So here, note, it's, you're not limited to using like checkpoints that are developed by Keras. You can use any checkpoint that's compatible with the model architecture. So here we have one that is from this research lab called New Research. I think that's how you pronounce it. It's French. And then, of course, you can also just use a preset that you have saved locally. And so, yeah, with that, we have over 200,000 checkpoints on Hugging Face that are compatible with Keras Hub models. This is how a Keras Hub model looks like under the hood. This is a bit, goes into a little detail here. But yeah, typically most models are divided into 4 parts. The consequences of this is when you call model.summary, say, on like a Gemma model, you'll see how it's actually divided into components, like the backbone and the tokenizer. And so that, I think, is a nice, not too fine-grained representation, right, of the layers in your model. And of course, you can train or fine-tune all your Keras Hub models using model.fit. But of course, these days, models are super big. So we want to, do some fancy customizations to model.fit, namely a series of techniques known as parameter efficient or fine-tuning, or PEFT. And so Keras Hub, you can do PEFT with Keras Hub models. Here the most popular technique is LoRA, low rank adaptation, where you just identify or a couple of matrices that you want to tune, and then everything else in your model checkpoint stays the same. It's super easy to do. We just call enable LoRA on the Gemma backbone, and we specify the rank of the matrices that we want to fine-tune. And then once we do that, we have our standard model.compile, model.fit APIs that you know and love from Keras. And then, of course, you can specifically serialize those smaller matrices to file. So that's how you do LoRA fine-tuning with Keras Hub. And then, of course, sometimes, LoRA itself is not enough, so you can also quantize your model weights. And so this case, we just call quantize before we enable LoRA. And so that's an even more efficient way of fine-tuning Keras Hub models. And then after you fine-tune your model, you can also upload your model weights to Hugging Face or Kaggle. So here, you've saved your model's checkpoint to a local directory, and then you can just upload that local file to a Kaggle URL or a Hugging Face URL. So that kind of describes the ecosystem integrations that we have with Kaggle and Hugging Face. Cool. All right. And then I guess since I have some time, I'll also go over Keras Recommenders. So Keras Recommenders is actually not out yet. This is kind of like a private preview or a sneak peek. If you go to any of those links, actually, you'll be able to kind of see it, but we haven't hard launched it yet. And so kind of this is the way it works in open source. We just quietly release things, and then maybe once we're ready, we'll do a big announcement or splash. So with Keras Hub or Keras Recommenders, you'll be able to build a JAX-based recommendation system in just minutes. Recommender systems are essential for creating personalized experiences, for delivering personalized recommendations. So, say you're watching a TV show, and then, a recommendation algorithm is going to tell you or recommend you, which episode to watch next. And So when building recommendation systems, scale is paramount. And so that's why we divide typically the recommendation system into several tasks. First, we have the retrieval phase, which efficiently filters for the different items. The ranking phase, which stack ranks the items and chooses the best one based on a certain metric. And then we, of course, have our multitask models that combine both the tasks. And all of these work with model.fit. Here's our selection of Keras RS APIs. So we have specific layers for feature interactions and retrieval. We have, of course, embedding layers, very important for recommender systems today. And we also have a variety of losses and metrics that you can use. Also coming soon, we have many tutorials and templates. So we've heard that the best thing about Keras is the variety of guides that it offers, and so Keras recommenders will be no exception. We're planning to release a bunch of starter tutorials to teach you the basics, as well as more advanced tutorials to teach you how to do more state-of-the-art recommendation techniques. Here we can take a look at one of their tutorials. We're building a recommender model called GRU for Rec. So this is a two-tower model. First, we have the query section, which we use, I think, a GRU layer there. And then we have our second model, the candidate model. And then we have our retrieval layer and our loss. We also want to and then in our call function, we'll combine everything to get the predictions. We also will override the compute loss function to calculate the affinity scores. And then all of that, I think, is combined and then called at the very end by the model.fit training loop. So with Keras recommenders, experimenting is super easy. You can easily convert this model from just a simple retrieval model to a sequential retrieval model on the right. And then the very special thing about Keras recommenders, especially if you're interested in using TPUs for doing large embedding lookups, is our new distributed embedding API. So this will allow you to take advantage of something called sparse core, which is a domain-specific hardware chip on Google's TPUs. So what this enables is you to shard your embeddings across multiple chips and then do some optimized embedding lookups there. So you can expect that in Keras recommenders in May. Great. And that was it. So I hope that was a good overview of the Keras ecosystem and the various APIs that we have for getting started training JAX models. Thanks, everyone.